Today I'm making a video about LED lights and how you can program them with a microbit. I've already made a video about this, but I have some new things I want to add. So first of all, why do we need to learn how to program lights? What is the purpose in real life? You can think of many instances where lights are used in society for things other besides just seeing. For example, there's a flashing light on top of cell towers. My oven has a light that comes on when the surface is hot. My car has an oil change light that when a sensor tells it the oil's old and needs to be changed, the oil light comes on. You can think about crosswalks that have lights that change, signs that change telling you when it's safe to cross. And even stoplights are programmed lights. So coders don't just program software for computers, they're also programming things in appliances and things around the city and in your home and in your school. So let's talk about how to connect this light. The LED light has two wires coming out of it. One is long, that's the positive side. The other wire is short, that's the negative side. We're going to connect the long wire of the light to pin 0, or whatever pin you use in your code. And we're going to connect the short wire with an alligator clip to the G&D, the ground. And so the electricity will flow from this positive side through the light to the ground. And I have to make sure that these wires under the light don't touch. If you do, you get a short circuit. So we're going to take a look at this simple code. Then I'm going to show you some challenges that you can do. And then I'm going to give you some hints on the challenges. And finally, at the very end, I'll show you the solutions. To make the flashing light code, I'm going to start a new project. I'm just going to call it flashing lights. I want the light to flash continuously, not just when I start my microbit, so I'm going to get rid of one start and have forever. I need to go down to the advanced section. If you don't see it, click on the down arrow by advanced. And I need to go down to this target that says pins. I have digital read pin 0. That's if I have a sensor. I'm going to actually want digital write pin P0 to 0. So what this code block does is it tells whatever is connected to pin 0, this pin right over here on the very left, it tells it whether to be on or off. In computer language, 0 means off, 1 means on. So if I'm digital writing pin 0 to 1, and I look over here, it has turned this pin orange, so it's on. Whatever's connected to it, today it will be a light, is going to turn on with this code. I don't want it to stay on though, I want it to flash off. So I'm going to put a pause after this, and the pause is going to tell the light how long to stay on before it goes to the next line of code. If I want it to stay on for 1 second, I can click 1 second or type 1000, because 1000 milliseconds is 1 second. So digital write pin 0 to 1 turns pin 0 over here on. Now I want to turn it off. I'm going to right click and duplicate this, or I could go back down into pins and get a new one. And now I'm going to say digital write pin P0 to 0, because in computer language 0 means off. And I want it to stay off also for a second. So I'm going to have a pause of 1000 milliseconds. So now when I look over here at my microbit, I can see that pin 0 is turning off and on for 1 second by turning orange and then not orange. There are other pins over here. Pin 0, pin 1, and pin 2 are the largest pins, and a pin is just where you can attach things. 3V is 3 volts, and that's when we need to supply power to something. And then G and D over here stands for ground, and that's where we need the negative electricity to flow to when we're making a circuit. If you click over here by P0, you can see that you can change the pins to pin 1 or pin 10 or pin 11. If I change it to something weird like pin 11, it's going to be one of these little blocks over here. And you can use those pins, but they're kind of tricky to get exact unless you have something called a breakout board. So I'm just going to leave both of these on pin 0. Here are some extra light challenges for you to try. Number 1, make button A turn the light on and button B turn the light off. Number 2, make the light flash fast 10 times on button A and slow flash 10 times on button B. Number 3, work with a partner to make a code that lights up 2 lights on your microbit. And number 4, work with a partner to make a stoplight. Red on top, yellow in the middle, green on the bottom. Make it like a real stoplight that changes automatically. If you are doing challenge 1, maybe don't get rid of this code just yet. Maybe go and get your buttons, button A and button B pressed. Maybe go get your buttons and then think. What do you need to put in button A that's going to turn the light connected to 0 on? What do you need to put in button B that's going to turn the light connected to pin 0 off? So that's a hint for the first challenge. For the second challenge, speeding the light up, I want you to play around with the pauses. What do you think happens if you change these pauses to either a bigger number or a smaller number? And then for the third challenge, can you code 2 lights at the same time? Think about what you're connecting the lights to. I have a light connected to pin 0. I'm turning it on and off. Could I maybe add another pin? Could I digital write pin to something else? Is there something else in here that I can do to put another light on the same code? For the last challenge, I made some notes over here, and I want you to think through this. You need 3 lights, a red light, a yellow light, and a green light. And which one do you want to start on? Which ones do you want to start off? How long do you want that light to be on? For example, if pin 2 is going to be my green light, and it's going to be on while the other 2 lights are off, how long do I want it to be a green light before it goes to yellow? So think through that. Okay, here is the code for button A turning the light on, button B pressed turning it off. We have on A, off on B. Here's one solution to challenge 2. I've got to repeat 10 times for the light on pin 0, and the pause is only 100 milliseconds. That's how fast the light will flash. On button B, I have the pause being 5,000 milliseconds, so it's going to be a slow flash or a slow blink. On for 5 seconds, and then off for 5 seconds. Here's a possible solution for 2 lights flashing off and on. First, I have pin 0 and pin 1 turning on with a 1, then I have them turning off with a 0. I actually probably want to reorder that because I like things to be in order. There you go. Pin 0 and pin 1 turn off, and then they turn on, and then they turn off, then they turn on. What would happen, just curious, what do you think would happen if I changed this one, pin 1 to a 0 up here, and I made it a 1 down here, pin 1 to 0, and then pin 1 to 1? What's going to happen to the lights now when they flash? Make a prediction and then you can test it yourself. And here's a possible solution for a traffic light. There's other ways that you can do this, but this is how I decided to do it. Pin 0 is my red light, pin 1 is my yellow light, pin 2 is my green light. First, the green light is on for 5 seconds, then I turn it off, P2 to 0, and I turn the yellow light on for 2 seconds. You only get 2 seconds to slow down. Then I turn the yellow light off, and my red light is on. P0 is on for 5 seconds. Green light for 5 seconds, pin 2 is my green light, then a yellow light for 2 seconds, then a red light for 5 seconds. And I will show you what that looks like too. So now I have all the lights I need for a stoplight. I've got the green light, so you're ready to go for 5 seconds. Then it switches to the yellow light for 2 seconds, and then the red light for 5 seconds. Then after that, it goes back to the green light. I have a whole tangle of wires. Pro tip, I use the same color of wire as the light. You don't have to, it just helps make organizing it a little bit easier. And then instead of trying to connect 3 alligator clips to the G and D, the ground, I have 1 alligator clip going to the ground, and it's clipped onto a paper clip that then has room for 3 other alligator clips. So yes, it's a whole tangle of wires, but it works. Have fun.